Hello, my name is Maria Garbete, and today we're going to talk about Chapter 13, Section 13.6, Directional Derivatives. To give a direction, we must have a vector, a unit vector, on the plane of the independent variable. Remember this. Vector has to be in the xy plane. That's the idea. We don't want a vector going to space. Okay, so things we need. We need a point for a specific rate of change. We need a vector, the unit vector on the xy plane. And finally, we need a dot product between the vector and the gradient f, will be the function. Let's just refresh a little bit. Remember that directional derivatives is just an extent of the idea of partial derivatives. If you remember, it has to do with a function with some kind of multivariable input, and I just use two inputs because that's the easiest way to start. Think about a single variable, ordinary real number output, just an expression of x and y and the partial derivative. So you do a notch a little to the x direction, and the resulting notch is in the output space, and the ratio between the original notch in the plane and the one of the output line, df over dx, is the value that you want. So now you are thinking of traveling in a different direction, so that's when you do a little notch to the y. So you got your notch to the x, your notch to the y, and now you need a vector. So now you do the partial derivative of df over dx, and you select a point 1, 2, and that's how you figure out your vector. So you draw your vector. So that notch in v has an effect on the function itself, and you start thinking about limits, something small, something that will approach 0. So that very small value, that will call h, and that h will be multiplied by the vector. Okay, so we got h dot in v. H is a very small number, as we said. It will be something like maybe like 0.001, and v will be our -1 and 2. Remember, it's the vector, and it will be -1 because negative notching to the x direction, it makes sense, and 2 nudging to the y direction, and the limit as h goes to 0. So the directional derivative is basically about the notches you did on the plane has an effect on the actual function. So we look at the notch on the v and the definition itself, and we got the ratio. So we put everything together, and we need to put in kind of like a notation. So there is like 3 kind of notations people use. I like to use the gradient, which is a little triangle upside down with the v next to it, the v as a vector. People use the partial derivative of f over the partial derivative of v. Some others just use the partial derivative and the little v on the next to it of the vector. Again, I will use the little triangle, our gradient, to just like put the gradient of the function equal the negative partial derivative of f over partial derivative of x, plus 2 partial derivative of f over partial derivative of y. That will be our setup. So as we can see, we see the formula. It looks just like the dot product. So we have our, for example, w, or v, the vector, within brackets will be a on top, b on the bottom, dotting our gradient f, which will be the partial derivative of f over the partial derivative of x, and the bottom's part will be the partial derivative of f over the partial derivative of y within brackets. So you got your w or v, whatever letter you want to choose for your vector, dotting the gradient or the notation you choose to put for your function. So it's very simple. We just need to remember the steps. We need the point, the vector. Finally, we set up a dot product between the vector and the gradient. We said it was the v times triangle f. Okay, based on the points I gave you, the information I gave you, you should be able to do this next example that says calculate the directional derivative of f xyz equals x cubed minus xy squared minus c. Remember, the f xyz will be our function, and then said at p 1, 1, 0, that's our point. In the v equal 2I negative 3j plus ck, that will be our direction. So remember, use all the information I gave you, follow the steps, and step by step you should be able to get 4/7 as our ratio for the direction. Thank you so much, guys. Remember to subscribe to my channel, give thumbs up, and we'll see you next time for more math videos. Bye bye.